Yesterday, we looked at creating and organizing our data. So we took a pause on new information to really practice those different data graphs that we could have. Today, we're going to take a look at mostly dot plots, but we could also look at histograms if we wanted to. We're going to take a look at some of the different sort of general patterns we can see to some of our data graphs. So again, we're going to look at dot plots in our notes, but we could also, to a certain extent, be talking about histograms. We're going to talk about, again, some of those general shapes that we can have to our graphs, shapes that we can have, sometimes we say to our data. And we're going to take a look at kind of what those different shapes can tell us about key information regarding the data that we've gathered. So if I take a look at page 8, we've got 4 different dot plots here that we're looking at. And what we want to talk about is what we see in our dot plots. Where's my data? Is it spread out? Is it clumped together? If it's clumped, how is it clumped or where is it clumped? If I've got data that's more spread out, is there a place where it's really thinly spread or not so thinly spread? So that's what we're going to take a look at to start for today. So as I look at A, I notice that kind of towards the middle of the values that we're interested in, we've got the majority of our data. If we were to find the median of this data set, I think we find it to be 15, either 14 or 15, I'm pretty sure it's 15. But when we talk about middle, we're talking about median, right? So towards the middle of our data set, we've got a lot of values here, right at the median and then right around it, okay? So we see sort of this clump of data in the center. And then as I move away from the center of those values that we cared about, notice that it sort of tapers off. I've got very few values here at the left end and very few values here at the right end. A lot of stuff gathered in the middle, not so much at the end. And again, remember the middle, we call the median, okay? The middle of all of those data values, those data points, is the median. So what we see here for A is that we have more data close to the median. For B, we see really exactly the opposite. We've got few values in the center, and then we've got clumps on either end. We've got this dip in the middle, but high points on either end. A lot of values near the low end, a lot of values on the high end. So a lot around my minimum and a lot around my maximum, almost nothing in the middle. So we have for B, more data, far from the median. For A, that data was close to the median. For B, that data is far from the median. For C, we have no clumps and we have no dips. Everybody's got the same amount. Every value that we looked at had the same amount of responses. So what we have here is a pretty evenly distributed set. Like everybody's got 3, even if not everybody had 3. If this guy had a 2 over here and it was some 3s and then another 2 and then some more 3s, that would still be a pretty even distribution here. So this is showing me data that's evenly distributed. And then our last graph here has a clump again, but it's off to one side. Where A, we had that clump in the center and it kind of tailed off on either side. For D, we've got a clump over on the right side. Got a lot of stuff up here, close to that maximum. And then it kind of tapers off here. We'll say tails off. So that clump isn't centered. It's kind of shifted off to the right. Say our data is lumped to the right. And these aren't the only shapes that our data can take. Just as we could have a lump on the right, we could just as easily have a lump on the left where it tails off on the right-hand side. And we've also got a couple other options for kind of big categories that our data graphs can take, different shapes that they can take. But these are some of the ones that we see pretty commonly. A sort of clump in the center, a lot of values close to the median. A dip in the center, a lot of values far from the median. Evenly distributed data or data that's kind of lumped on one end or the other. So all of these different types of distributions have names, and that's what we're going to talk about next. So do we have any questions on page 8? Okay, so let's go ahead and turn to page 9. The one thing that we might care about when we talk about the shape of our data is whether or not that data is symmetric. So when we talk about our data distribution being symmetric, what we mean is that the left and right sides look the same. And when I say look the same, what we want are mirror images. That means that if I were to fold it in half at the middle, the left side would match up exactly with the right side. Our first distribution on page 8, if I were to cut it in half, it's not perfect, but it's a pretty good example of a mirror image data set, right? If I were to cut it in half around the middle, which would be about here, this side matches up pretty well with the other side. It's not exactly perfect, but it does a pretty good job. Okay? So that would be an example of a symmetric data set. So A was symmetric because if I cut it in half, the left and right are mirror images of one another. Think about if I fold it along that line, this side would match up with this side. B C, which is kind of the inverse of A, has that same property. If I were to cut it in half, the left side and the right side are mirror images. They match up. So that would also be symmetric. If I can cut it in half and the left and right match up, that's symmetric. We had one more symmetric distribution on the last page. That'd actually be C. Since my data is evenly distributed, if I cut it in half, the left side and the right side are going to match. Since it's the same everywhere, if I cut it in half, the left and the right are going to match. In Algebra 2, we're going to talk a lot about bell-shaped distributions. We'll call them normal distributions. Bell-shaped distributions are called that because they kind of look like a big bell. And they have like the general shape of the outline of the Liberty Bell, which we'll draw here in just a second. They are usually symmetric. And with a bell-shaped distribution, most of our data is close to the center. And in a bell-shaped distribution, the center is the center is always the median, but it also ends up being the mean. For a perfectly bell-shaped distribution, which we don't find a lot in real life, usually there's a little bit of a high end or low end, or maybe a slight skew, but in a perfectly bell-shaped distribution, the mean and the median will be the same. And it would look like this, which is, again, similar to A. This is what we would call a bell-shaped distribution. Now, if my bell-shaped distribution isn't centered over the median, if it's kind of tipped to one side or the other, kind of like if I took this and like pushed it over, or took this side and sort of pushed it over, that's what we would call a skewed distribution. If we skew left, we've got a clump of data, and then we name these skews by where the tail is. We have a tail on the left. So that would be like D. That tail is on the left. We could have sort of the mirror image of this as well, where we've got a big sort of a lump of data on the left and then that tail on the right. But the big idea, no matter which skew I have, is that my data is lumped to one side. I've got more of it on the left than the right, or vice versa, more of it on the right than the left. And again, we name these skew left or skew right based on where the tail is. So we didn't have an example of skewed right on page 8, but it would be the same idea as D, but sort of reversed. Questions for me so far? For a uniform distribution, what that means is that my data points are uniformly spread throughout all the values that I could have. So that looks like C, right, where we're evenly distributed. So again, that would look like C, where I've got the same amount everywhere. For uniform distribution, if I'm off by a tiny bit, this spot right here is actually a little bit lower, and maybe this spot is actually a little bit higher than that everywhere else. That's okay. That's still a fairly uniform distribution. If I've got something that's way bigger than everywhere else or way smaller than everywhere else, then that's where I may not call it a uniform distribution. But if generally I've got the same values for everything, the same amount for each number, then that's uniform. And then the last one that we'll talk about, but we didn't have an example on page 8, is something called bimodal distribution. So a bimodal distribution would be data that has two what we'll call peaks. It sort of looks like if I took a couple of bell-shaped distributions and put them together. It would look something like this. I would have a peak and then another distinct peak. That's bimodal. So it kind of looks like two bell distributions together on the same graph. You could also have more than two peaks for your data, and that's what we would call multimodal. So if it's more than two, we would call it multi. Two, we would call bimodal. But multimodal might look something like this, where I've got a peak, and then another peak, and another peak, and another peak. If I've got a bunch of peaks, then that's what we would call multimodal. Questions for me on page 9 on any of those distributions? Okay, so distributions can fit one or multiple of these descriptions. We saw as we worked through, as we talked through each of these, that A was both symmetric and bell-shaped. C was symmetric and uniform. So we can have distributions that fit more than one of these categories. We could also have distributions that really don't fit any of these categories, but these are the big ones that we're going to focus on. So on page 10, I want to do a few practice problems together where we identify and describe the distributions that we're looking at. So if we look at A on page 10, which of those classifications would fit for A? Sophie? Yeah, this is a symmetric distribution. I could cut it in half, and the left and right are mirror images. This is symmetric. Good. Definitely not uniform, definitely not bell-shaped, definitely not any of those other categories, but it is symmetric. What about B, Nevada? This is bimodal. Yeah, it has two distinct peaks. Bimodal. Is there any other name I could give this one? Mm-hmm. This is also symmetric. Yeah, I could cut it in half and the left and right would match up. Good. That one's bimodal and symmetric. What about C? Sophie? This is bell shaped, yeah. That peak in the middle, and then it tapers off on either side. That's bell shaped. It is also symmetric. Yeah, if I cut it in half in the middle, we've got, looks like the same thing happening on the left side as the right side. I could fold it in half and it would match up. This is also symmetric. And then what about D? Skewed right. Yep. Definitely not symmetric, not bimodal because I don't have more than one peak, not bell-shaped because it doesn't taper on both sides. This is skewed right. Remember, this always seems kind of counterintuitive to me. I want to name them after where the big clump of data is, but they're named after which side has the tail. And the tail is on the right here, so this is skewed right. Okay. Questions for me on those? Not too bad? Those shapes? Okay. So for the rest of class, which is a decent chunk of time, I want you to work on your homework assignments. So these 3 Khan Academy assignments listed here at the bottom of page 10. These are assigned to you in Khan Academy already. So they're going to have you do some more practice with identifying those shapes, a couple of questions on that. And then you're going to look at how we can compare distributions. So for example, if I collected data from all my different classes and whatever it was, height maybe, and these were the results from my first hour class, and these were the results from my second hour class, I want to know, what does that tell me? Or if these were the results for the height for my second hour class compared to my third hour class, what does that tell me? Okay. And then the last one here, comparing data displays, you're looking at which of these different graphs that we've talked about would be maybe most appropriate, or what kind of information can you get from each of those different graphs. So if I look at a dot plot compared to a box plot, what kind of information do I know? Or what kind of information can I see or get from that different data display? Okay, so those 3 I want you to work on. Let me stop screen sharing for just a second.